Hey everyone, and welcome to This Explainer. I am so incredibly excited to have you here today because we are going on a totally fascinating virtual factory tour. We're going to take these really complex, real-time plant unit operations and just break them down in a simple and easy way. We are literally tracking the journey of a rock, following it sequentially all the way from the raw earth right up to the construction site. It's an industrial marvel that happens every single day, and by the end of this, I promise you're going to see the built environment around you in a totally new light. Okay, let's dive right in. Our roadmap today is pretty straightforward. 1. Quarrying and initial crushing. 2. Milling and blending. 3. The heart of it all, the rotary kiln. 4. Cooling and final grinding. And 5. Quality control and dispatch.
You know, it really all starts with this one super fundamental question. How is cement actually made? We drive on it, we live in buildings made from it, we cross bridges supported by it. But the hidden mechanics behind this modern infrastructure? We almost never think about them. So today, This Explainer is your ultimate guide to understanding exactly how raw earth is transformed into the foundational glue of our modern world.
All right, Section 1, Quarrying and Initial Crushing. Let's get into it.
First things first, we actually have to get the raw materials out of the ground. Step 1 is extraction, and let me tell you, this requires some serious power. We're talking heavy-duty drilling and blasting to extract specific minerals: limestone, clay, silica, and iron ore. Next comes Step 2, transportation. Massive, and I mean massive trucks, move these raw, jagged materials out of the quarry and over to the cement plant. And once they arrive, well, we hit Step 3, which is crushing. These giant boulders are fed into industrial crushers that rapidly reduce the huge rocks into smaller, way more handleable pieces, because otherwise, they couldn't actually be processed in the plant.
Moving right along to Section 2, Milling and Blending.
Okay, so in this zone, those crushed materials are sent to the raw mill. Now, you'll often hear industry folks throw around the jargon raw mill, but honestly, this simply means a very fine powder. Inside the raw mill, our crushed rocks are thoroughly dried and meticulously ground down until they become this raw mill. We have officially gone from giant boulders to fine dust.
Now, once we have that raw meal, it doesn't just sit there. It gets transferred into incredibly large silos where it's blended. And maintaining precision at such a massive industrial scale is absolutely vital. The chemistry here has to be perfect. This blending guarantees a perfectly consistent chemical composition, which is a totally critical prerequisite before we expose it to the high heat.
Which brings us to Section 3, the heart of the plant, the rotary kiln.
800 degrees Celsius. The raw meal first enters the preheater tower. Here, hot gases traveling up from the kiln preheat our powder to this intense temperature. And what's really amazing here is the efficiency. By using the hot gases that are already being generated by the plant, they significantly reduce overall energy consumption. So the material is practically baking before it even reaches the main event. Let's look closer and see how this builds, literally. After the preheater, the material passes into the precalciner. Here we get some real-time heavy-duty chemistry happening. Most of the limestone, which is chemically known as calcium carbonate, undergoes a profound chemical conversion. Under these extreme conditions, it transforms into calcium oxide. The rock is fundamentally changing at a molecular level right before our eyes.
And then the heat gets turned up even more. 1,450 degrees Celsius. No way, right? That is unbelievably hot. Now the material enters the true heart of the plant, the rotary kiln. Contrasted with the precalcinator, this is a whole different level of extreme scale and intense heat. Inside this massive rotating cylinder, the raw meal is pushed to its absolute limits.
So what does this all mean? The crucial point is what actually emerges from this 1,450-degree inferno, and that is clinker. Because of the intense chemical reactions happening inside the rotary kiln, that fine powder fuses together to form small, hard nodules. These dark gray nodules are the clinker, and this right here is the main ingredient of cement. The rock is efficiently transformed into the foundational element we need.
All right, Section 4, Cooling and Final Grinding.
So, after coming out of the kiln, that incredibly hot clinker moves directly into the clinker cooler. Here, it gets rapidly cooled down by an array of really powerful air fans. But wait, remember those hot gases we talked about earlier? The plant's clever engineering captures the intense heat blowing off the cooling clinker and reuses it back in the process. This massively improves the factory's overall energy efficiency.
And once it's completely cooled, the clinker is safely stored away in silos, just waiting for the final step. Now, clinker alone isn't finished cement. It requires a highly specific mixture. Taking clinker as the base, the plant adds about 3 to 5% gypsum. This is actually to strictly control the setting time for when water is eventually added on a job site. And depending on the exact cement type, specific additives like fly ash, slag, or extra limestone are introduced here too. It's like a giant, very precise recipe.
To finally bring the journey of the rock to its final physical form, this highly specific recipe is fed into the cement mill. The mill grinds this mixture down into a remarkably fine powder. And there it is. We have created the finished cement. The real-time manufacturing sequence of the material itself is totally complete, and this finished cement is sent to dedicated silos for safe storage.
And finally, Section 5, Quality Control and Dispatch.
When it's finally time to leave the factory, there are a few primary dispatch methods. For smaller projects or retail, the finished cement is packed into those familiar 50-kilogram bags. But for major infrastructure projects, it's loaded directly into massive bulk tankers. From the plant, these trucks hit the highway, delivering the cement directly to construction sites globally to become the buildings, bridges, and roads we all rely on every day. Now, behind the scenes, this massive operation balances two huge priorities: quality control, or QC, and HSE, which stands for Health, Safety, and Environment. On the QC side, strict laboratories are continuously testing the materials to ensure they absolutely meet international building standards. Meanwhile, robust environmental systems like bag filters and electrostatic precipitators actively control emissions, alongside rigorous safety procedures enforced to protect the workers. It's a massive balancing act.
We have just tracked the complete journey. Just think about the epic scale of what we've walked through today. We started with a raw, violent quarry blast out in the elements. We moved through crushing, milling, and precise chemical blending. We traveled through the 1450-degree heart of a rotary kiln, and finally into the cooling, brinding, and dispatch of a fine gray powder. That powder is literally the foundational material for the infrastructure of the entire world.
So I'll leave you with this final thought. Next time you drive over a massive concrete bridge or look up at a towering skyscraper, are you just going to see a static gray wall? Or will you look at it and actually see the 1450-degree journey that rock took to get there? Thank you so much for joining me on this explainer today. Keep learning, keep questioning, and I'll see you next time.